Hello, GM everyone. Day 3, and we are back. Today, we are going to write contract that hosts elections on chain. Now, this is fundamentally the first contract that is ever written in any bootcamp, any Web3 course you get around here. So, what are we going to do is we are going to host elections on chain. So, elections have something called votes, and votes are given to candidates. So, these are the three entities that we have established for today. Now, let's try to get into all the entities first, and then we will get into what the actual structure of the contract will be. Now, the first thing is we need something called an election. Okay, so election will have its name of election, like presidential election, whatever. It can be a class monitor election, something. It can have a candidate array where all the candidates are present. We'll architect the candidate type soon. Let's first go with elections. Now, the names will also have something. This elections will also have something called addresses, mapping of address, right? And against them, if they have been voted for or if they have not been voted for. So basically, this mapping will be for is an election on or off, right? On or off, okay? And after this, we need to define if there is like the total amount of votes in that, which will be determined from the candidates and all. But we can actually go for a time ending, time ending for this, okay? So if time ending is more than what time decided, time current is now, the election is still on. So let's give an example to this. So if time ending is, oh, I have spelled this so wrong. Time ending is 12:30. So the time currently is 12:20, and hence this time ending is more than what time current is. So election is on, else it will be off. Okay, so that's understood here. Now let's think of what the candidate will have. The candidate will have something called name and votes. So votes count. Okay, these are the two fields that the candidate needs. Now what do we need? There will be an owner of this contract, so he will have create election function. Okay, create election function. After create election function, we will be using something which is very important, vote for. And this vote for will have something that is taking vote for any election ID. So election also needs to have a unique ID. Every election needs to have a unique ID because there can be two presidential elections, right, at once going on. And after vote, we need getter functions, which is get vote count. Get vote count. And get vote count, we need to see what candidates are present. So get candidates. Okay, this will be here. Now today we will write deploy scripts using AI so that I can lead you through of how to test a contract, because deploying this contract is not our fundamental objective for today, as we have deployed contracts previously. We will test this using the forge test scripts, right? So let's initialize the project. Let's go for cd defer is ls. Let's make day 3 and day 3. And let's go for close this. So what was the command? The command was forge init, and let's initialize an empty forge project here. Okay, now as usual, so here you can see that there are test scripts written. So these test scripts, what they do is they test each function of your contract, right? Now let's make the three files go away, and yeah, don't ask me again. and let's open the source where we write elections.sol, right? Now, as usual, SPX license identifier NID pragma solidity. I don't want this, I want 20. I use different versions every day. It doesn't matter unless you're writing something that needs the version control and some specific function from some specific type of Solidity versions. Now let's initialize this contract election, and this contract will have the functions and structs. So let's go for struct elections, and this election will have a name string. So I was going to write the JavaScript syntax, but no, name string, then string description. Yes, we will need description here, and then we will need start time. Oh, not actually start time. Nah, we need a start time. We need to see if the time has been passed or the election has started or not. Basically ये check करेंगे यहाँ पे, and then we need an array of type candidates and mapping of address bool has voted or not. So if an address has voted, they cannot vote again. Now let's make the struct candidate date. Let's keep this and candidate and string name. We can have multiple things here, and party and vote count. Should we do this again? I think we can do this easily. What's wrong here? Identifier not found, so let's just put this above. Okay, Control X, Control V, struct candidate. Okay, candidates, and boom. I guess these are the structs that we need. What is here? Declares struct election type. Let's keep it types for now. Okay. Now, what functions do we need and what mappings do we need? So the first mapping that we need is UN to election data. So how many elections are going on? So we get an election ID for the elections. Okay. So we need a mapping u into 56 to election type, which will be public elections. Then we need a u into 56 public election ID. Okay, we'll initialize this with 0. Then we'll keep it increasing. So the constructor will have a message.sender is equal to, and we'll have an address which is owner, map and public address, public owner, message.sender is equal to so here owner is equal to message.sender, and then what we will do is we will initialize the election ID to be 0. Okay, so the first election will be created, will have election ID as 0. Okay, now first function that we need is something that is create election along with an access modifier called only owner. So that only owner can create an election, not everyone else. Or yeah, let's keep it under control for now. We can have multiple ways of making this decentralized so that everyone can create an election with whatever parties and whatever candidates they want, but that will be very chaotic. Elections and voting need to have some sort of centralization in that, so let's ensure this. So we have this modifier only owner. I created this yesterday also, and let's keep it here. And for then just a second, let's keep it here. Oh, why is this a problem? Oh, okay, understood. Yes, yeah, this is okay. This here, and only owner can follow this function. So let's make some custom errors. We don't want this strings error not owner, and let's go for if message.sender is not equal to owner, return, and boom, 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 and function create election which will take some parameters that we'll decide, and it will be an external function and only owner function. Now this will take let me see, name and party, which will initialize with 0. So it will take string array, string memory names, candidate names, comma, string array. We can actually pass a struct here, but let's keep it like this. Memory candidate parties. Okay, let's toggle wrap here so that it's easy, and we can do this actually so that it's easy to read. Okay, and external only owner. Now what does it do? It checks first if length of candidate's party and must have, so it should have mismatch length error. I think I should make a module, basic start to get module, election length mismatch with all these errors and stuff so that I can reuse them. Length mismatch, so reward with reward length mismatch. Okay, that's fine. And can now do the actual for loop and whatever we need. So election type storage, elections ID, election name. Oh yeah, we need an election name also, string memory name. So this will be name. Okay, name. Then start time is equal to, oh, we can actually take start time. So string memory description, and you want to start time and you want to end time. Okay, remove or comment of the variable name to silence this warning and use function. Oh no, we are going to use this. Description is there, start time is here, end time is here, and start time has to be less than time, so we can do this party 0 whatever. Okay, and this will return an election electionId plus plus. After the for loop is done, we go for electionId plus plus and return electionId minus 1. Why electionId minus 1? Let's think about it. It's 0, so it will be incremented first, so it will be 1, but the election that is created is actually at 0, so we need to return minus 1. Okay, and this will also emit. My keyboard has been not working well, but it's okay. Event, let's keep events here. Event election created, yeah, that's okay. Emit election created. This is wrong. What's happening? Unreachable code. Yeah, because we have put this beneath the return. Now it is reachable, so create election is done now. Now let's create the vote function, and vote function will need something called election ID basically. As what are the election ID that we are calling vote, and it will need a u into 56 election ID, and against that election ID will be a callable function and returns bool. Now if it returns bool, then we need to first find the election ID from this election struct, that is this election type. So let's do that, and we will go for, and we'll actually increment the address of the sender to be at, if let's say, let's go one by one. It's too much. Okay, Yeah, so this will actually, the first case will be for checking if the election has started. Checking if the election has started. If check if the election has started, and if block, and if block dot timestamp is less than election dot start time, or let's write an or block dot timestamp is greater than election end time, whatever it says, yeah, where return false. I think it should not return bool here. I'm not sure. What should we do? We can give each vote an ID, but that will increase a lot of storage here. So let's think about this. Yeah, I guess we don't need a return type in this function actually. No, let's keep it. Revert that election has not started, election not active. And let's make an error here. Election not active. Where is the errors? The election not active error is done. Now, if message dot sender, no, election, yeah, it is true already. So what have we done? So elections of election ID has voted, then message dot sender. So if this is true, then return false. So return with already voted. Okay, and let's create this error here. Already voted. Okay. Now these are the two test cases. These are the two callbacks and fail safes that I want in this election. And if everything works, then why is this still not okay? Already voted is here, brother. Let me refresh the window. It takes time sometimes. Yes, now it's done. Okay. So nope. Okay. So if everything goes through, so elections has voted is equal to true. So let's find the candidate. Yes, we'll find the candidate. And this is revert. Oh, actually we have to revert. I've written wrong thing. So let's find the candidate, and so election dot candidates of 0 dot vote count plus plus. We'll actually also take the candidate name here. String memory candidate name. Okay. So we will find us, and this error is bugging me, man. Okay. This is okay. Now, what does this logic say? Elections.candidate. Wow. Now, this is interesting logic here. We can use this, but let's understand what this actually means. Okay, let's take a moment and understand what this actually is. So Kechek is Kechek 256 is an encoding algorithm. So you can read about it here. 56 algorithm. It's the hashing algorithm. It hashes the data into 256 bits. So whatever fingerprint data. So why is it used? Okay, so let's think of this and see why it is used. It is used for hashing data. It takes that input and computes its hash, which is always the fixed length bytes of 32. The one-way cryptographic hash function ensures that original. So we encode data before hashing and generating unique identifiers. Okay, so now the vote function will have this thing. So what do we need here? Okay, so either let's think of this. Either we can go to this election and election candidate, and we find from candidate names. What do we have done? Election dot I dot name is equal to no, we need to improve this logic. So we need to find the candidate in the election struct, and then increment their vote count by 1. Okay, so now let's write this for u into 56, I is equal to 0, I less than, actually this would be right, that avi.encode back elections. The good work will be, I'll write a doc. Now let's see what's happening here. So the candidate name has been hashed to prevent name collisions. Exactly. So let's give an example of how hashing works. So here is a name and here is another name. Now these two names produce different hashes. This hash is different. This hash is like this, and its hash is always like this. Okay, these are two different hashes. We can use this easily in our terminal. So echo I'm not sure if my terminal has catch-up 256. I'm not sure if it has catch-up 256, but let's try this. Nah, it does not. It does not. Shot 256. Yeah, this gives a hash, and this is just another algorithm which is used for hashing. Now let's go for the another name. So tv, and then this is the thing that we're finding. Now let's write the getter functions. I'll explain this vote function as we go to testing, because this is where we will see that how do we actually test if these functions are working. Now we are getting the get elections and get candidates. Actually I need to get all candidates, so this function would be array, not this function get all candidates, and you will do 56 election id, and this will be actually a getter function that will loop through everything. So let's say external view returns, what does it return? It returns a candidate memory and dot candidates. Yes, this will be returning all the candidates in this. Now what is the problem here? Mapping can be only used, returns, yeah, it got solved. It does not, it did not get solved. Now let's solve this error first. So election type memory. Now we can do this and we can have nested structs here, because this is a nested struct. This has a struct, and inside this it is also another struct, right? So we can also let's make the getters first. So function get election result. Okay, and you will do 56 election id external view return candidate memory, and we don't want to return the candidates, we want to return the candidate with highest vote count. Okay, so what will we do is we'll go through all the candidates, and highest vote count is equal to 0, and simple algorithm of finding the highest number, right? So, and we'll return a count. This is what actually we need. So this is very simple function that can be called here. So what is it doing is just making an array of candidates. So it gets all the candidates from an election id. Now it finds the highest vote count. Okay, so highest vote count, if it is greater than 0, then it gets updated, and if it's not, it does not get updated. Okay, now it finds a winner count. So similarly, as the winner count increases, okay, So, and simply it returns the winners, but actually we do not need this. And string memory winner, okay, and we return winner is equal to name and return winner. That's what we need simply. So it will just return a string memory, and yeah, now it works. Okay, should we check if the election has started or ended? And yeah, let's just fix this first. Okay, so returning election ID. So rather than doing this, what we can do is get election. So it will be returning all these things. So you will do 56 string, start time, end time, candidates. Yeah, these things it will be returning. We can do this, and then once we are through this, so we can go for this, and then we can name, description, start time, end time, candidates, and return. I think this does it. There is no error here, except there is one error somewhere around here. Let's see the problems. Okay, it's just comma is needed here rather than this. Okay, that fixes it. Let's memory. Okay, yeah, whatever. Let's do this. It's very important that the time is right here. I have tried to keep this video short so that we can actually go for expected, but okay, whatever. So this is our contract written, but this is a complex contract, so we need to test how this contract is actually working. So let's go to test and let's create an election test.t.sol. Similarly, as how we created an s.sol, which was a deploy script, this will be a t.sol, which is a test script. Okay. Now let's go for spdx license identifier MIT Solidity is greater than 20, as we know that we need to match the version of Solidity. Now let's import for std test.sol here. So let's just do this, and we don't need actually console.log, but let's import console.sol. Okay, and let's import the elections. Now let's test a simple now what does a test file comprises of? It comprises of a setup function. Okay, so a test file why am I doing this wrong? Test file. Now test file comprises of a setup function. Is it all purple? Yeah, it's white now. It comprises of a setup function which sets up the environment for testing. Okay, now this means that it deploys the contract in mock environment, in like testing environment, and gives all the parameters needed. Okay, and then whatever it does. Okay, so one good way of writing test scripts is to go function by function and then test them. So we will do that for 1-2 functions, and then we will return to AI for writing good tests. So contract election test is test, and then we will go for address owner. Okay, and election not really. What we will do is function setup what is setup, right? And then we've got public. It will be public function owner is equal to vm.address. VM is the same library that was making the mocks yesterday using deployment. Now it's the same thing. Now there is something called vm.start prank and vm.stop prank. So when we call vm.start prank, the address that is given in vm.start prank, that is owner, will do all the interactions with the functions or contracts that we're calling. So vm.start prank and vm.stop prank, and in between we will set up our contract. Now this is very easy if done right by AI. Okay, vm.deal ether election is called a new election, and election has a constructor. What does it need? It just need a message or sender, and it initializes election ID 0. Now let's console log the election deployed, and this is done. And if let's just deploy the election contract first, and if election owner is not equal, revert to owner. Yeah, and console.log elections. Okay, that's it, what we need. Okay, now let's run the setup function. I'm not sure if it will run because it's just a setup function and no tests are written. Yeah, no tests are written. So we need an election. Yeah, this is the actual setup function that we need without the console logs. So, and now let's try to create an election first. Okay, function test create election. Okay, and it will be public. Now we need a lot of things here. That we need a memory of name. Let's just give it here. Memory name, description, start time, end time. Okay, now let's give this presidential election. This is a test election. Start time is equal to block.timestamp. We'll go block.timestamp of 1 day, so it will work for 1 day, and will be candidate names will be Alice and Bob as usual, and candidate parties will be party A and party B. Now UN256 election ID is equal to election.create election. If assert equal should be equal to name, should be equal to start time. Now just let me write this function first, and then we will go for what the actual data is being written and tested here. Now assert equal means that we need to see if the election ID would be 0, actually not 1. Election ID will be 0, description, start time, end time, whatever. We don't need this, we just need until here. Okay, so we need all these things. So what we are doing is we are creating an election first. What's the error here, man? Expected primary expression. Oh, just a typo. Unnamed return variables. This is vote and returning true. And returns. Oh, actually, we don't need it. Actually, we don't need a return type here. But break, and then we emit voted successfully, and what we need in here is message.sender, election ID, and candidate name. Let's create an event for this. Sorry to switch back here, but we need to have right events here. Voted successfully, done. I think there is one more problem here. Yeah, sorry guys, just a typo here. Now let's test this function. Now the way to test this function is to call forge test. Just do the font increase in my terminal. Forge test / empty, and we call this, and we call this function. So what is the problem here? Block.timestamp. Oh, sorry, I have written commas everywhere, guys. Sorry. So let's first build this file. let's see, there is some error here. Is only valid in storage because contains test mapping, different map plan, and the right side. Created election. Let's forget this. Okay. Let's just test if the election. We have getter functions for get elections. Okay. So we can call that function. Okay. So let's call that getter function. So not const, election type of created election is equal to election dot get election ID and name description. Boom. Okay, what is the problem here? Number of left side and the right hand side. Left hand side we have 1 and right hand side we have 5. Let's fix this. Okay, baby. Let's try to do AI here and see if it works. Quick fix with AI. Okay, bam. So I know where this is flopping. We need one more keyword here. So let's say that give the ChatGPT the contract that we are trying to modify here. So elections.sol is the contract. So just give it the contract. I am writing tests for this contract and running into this error. Now the error and the setup should be given to them. So address owner, whatever. Okay. And the error is written here. This is the data that you provide to any AI that can help you. At first, you're trying to destructure a tuple with 5 return values. So yes, what do we need here is created name, comma, created description, comma, created description. Spelling is wrong. Let's go for this, and then created start time and comma created end time. Let's go for this. So what does this return? It returns get election. It returns with start time, end time, and description and candidates. Okay, so that's all we need here. Oh, sorry, this is what the structure is. Okay, this is what it has done. So we'll go for this ID and boom, we have this here. So name return, name description, and now we'll just assert equal. Assert basically will return true if both things match, and it will return false if it does not match. Name return should be equal to name, description return, start time return, end time return, and candidate return line should be 2. Name should be candidate names of 0 and party. So we can test everything here. So AI is very good at writing the tests for any kind of contract that we have given. Election ID will be 0. Okay, or 1, I guess. Yeah, it will be 1. Yeah. Okay. Cool. Let's call this function now. Boom. And it is failing because what's happening is we are not the owner of this function. So we have to vm dot, oh, there is something that happened here that we wanted to happen. So create election can only be called by owner. So this is where we see that this is only function only owner function, and modifier is right into the action, right? So vm dot start prank owner, and we'll stop it here. vm dot stop prank here, and it's okay. This is not an error. It's not an error. Yeah, let's go. Let's fix this. So everything was right. Now if we want to read through these logs, we can call /vvv, and then we'll have all the presidential election, test selection, whatever we need is right here. So this is how you write tests. We can write tests for all the functions here. Now this is very easy. So write a test for vote function, right? So let's write for a vote function, creates an election cast a vote, verifies the vote was counted, checks double vote. Okay. Now let's do this. We created an election. So this is the test we have. We need to read through this test actually so that we know voter and there is candidate name. So string, we need to go for this memory candidate names. That will fix this error, and this will also be new string 2 candidate parties. Now let's call this function forge test slash empty is basically match test name. So the test name that you'll write here will match, and let's call it with logs, and this works. Boom. So let's read through the logs here, and we can see that they have been voted right. Everything has been asserted right as the vote count, and everything has increased, and the other guy's vote has not increased. That's what we need here. So this is how you write. Now there is something called forge coverage and the forge complete test, right? So let's open the terminal. The keyboard is misbehaving today. And let's go for forge test. So all the tests will be called in this one, and when we go for forge coverage, it will give us the complete coverage of how many functions have we tested. Elections.sol, we have tested 6 of 7 functions. We have not tested the getter functions here. Branches means if one branch of function is, it should execute, and the other branches it should fail. This is how we write the test scripts, and that's all for today. I hope you had learned something, and the next contracts that we will write, we will all have test files, we'll all have deployment scripts, and soon we'll get to how to connect this to a front end where you can open a MetaMask wallet and then sign your transactions. Thank you.